Okay, here we have another one that has a fourth power. Now this one's going to be different, so before you stop the video, this one's a little bit different because at the end we're going to have to use the quadratic formula. So the previous examples I did, you had to factor the end one, but this is one you'll have to use quadratic. So this is going to be a little bit different. Okay, not to spoil it or anything. Okay, so first for part A, we want to use the rational zero theorem to find the zeros. So we're looking for factors of 65 divided by factors of 2. So on top you do factors of 65, 1. You're going to get 5 will go in there, and then 13, and then 65. On the bottom you get plus or minus 1 and plus or minus 2. That's factors of the first number. So factors of the top number divided by factors of the bottom number. You want to write this out as a list. Again, you can't keep your answer in this form. You want to write all of it out. So we're going to expand everything. We're going to do plus or minus 1 over 1 is 1. And then 5 over 1 is 5. We get 13. And then we get 65. All the numbers on top divide by 1. Now we'll take all the numbers on top, divide by 2. So plus or minus 1 half, plus or minus 5 halves, plus or minus 13 halves, and plus or minus 65 halves. Okay, so that you get 8 of them. So you get these whole numbers here, then you get the fraction one, so we have 8 total answers on that one. That answer is part A. Now for part B, this is where we're going to use synthetic. So this is where you want to use a graphing program or a calculator to figure out what places the graph crosses the x-axis. You need to have at least 2 numbers to use with your given one, because we have to take it down from a fourth power down to a quadratic. So you need to do synthetic twice. That's why we need 2 x-intercepts, or 2 numbers that we get from a graph. So I've already done that already, and I got 5 and 1 half as 2 numbers where I see the graph crossing. So I'm going to do synthetic with that one. Now it doesn't matter which one you start with first. I'll start with the 5. And we have this one. This one's written in our proper form. You should always be making sure that you have all the terms available. There's no term missing and the powers are descending. We should always be doing that first to make sure we're setting it up correctly. So we put 2 in there, and then 1, negative 35, negative 113, and 65. So these are going to be just the coefficients from the first one. And now we're going to do our synthetic steps. We bring the 2 down. Multiply those, you get 10. If you add it together, you get 11. Multiply these, you're going to get 55. If we add that together, we get 20. Multiply that, it's going to be 100. Add it together, negative 13. And when you multiply negative 13 times 5, you get negative 65. When you add it together, we get a 0. So again, we should expect to get a 0, because if we saw that number from the graph, if we see the graph crossing at 5, then we know for sure that's going to be an x-intercept. We should get a 0 as remainder. Now we're going to do the next one. Next one is 1 half. We're going to use our answers that we got for the previous one. So we have those. And once again, we're going to bring down our first term. So bring down the 2, multiply that. 2 times a half is 1. If you add that together, you get 12. Multiply that, you're going to get 6. Add it together, you get 26. Multiply, you get 13. Remainder of 0, again, you get on that one. Alright, so now what I have here, I want to turn that into a polynomial. It was a fourth power. I'm taking it down into a square because I do synthetic twice. So you get 2x squared plus 12x plus 26. That's going to equal 0. Now, as far as factoring is concerned, we do have a common factor we can pull out, so I'm going to pull out a 2, and you get x squared plus 6x plus 13, and we have that equal to 0. Now I'm going to hold off on this. I'm not going to solve this just yet because I want to go ahead and do part C first with the factoring, since we have it in this form. This particular one here does not factor anymore because we can't find factors of 13 that add up to 6. So therefore, this piece right here is actually going to be part of your answer. So because we can't factor that anymore, we're going to go ahead and have that down as part of our answer, x squared plus 6x plus 2. Now, don't forget about the other 2 things here. These 2 we found by using graphing or trial and error. You're always going to do x minus the 0, so we're going to do x minus 5. And the other one is going to be x minus 1 half. What I'm going to do is I'm going to take the 2 and I'm going to multiply it by this one. Now the reason why I'm doing that is because that way I can get this out of here, because usually your answer, you don't want to leave your answer with a fraction there. So I'm going to take the 2 and multiply through by that one. So with multiplication, you're allowed to do that in any order. So I'm going to multiply 2 by each of this. Now if I take 2 times the x, I get 2x. 2 times a half, I get minus 1. So if I'm writing the factored form, this is what it's going to look like. I have the 2 times the x minus 1 half, that gives us 2x minus 1. Then I'll write the x minus 5. And then I have this other piece left over. That would be my remaining one. So that would be the answer for part C. We have all those there. If you multiply all that together, you will get the original one. 2x, x, and x squared. That gives you the x to the 4th power, so that's going to be part C. Now, what about this part? We haven't solved this equation yet, this one right here. So, I'm going to create some more room for that up here, and I'm going to show you how you would do that. So, we had the list of rational zeros that I just erased. We had 5 and 1/2 came from that. However, if you have to use the quadratic formula, you will not see the answers on that list that we had before for part A. Let's do this one. Now, for this, first of all, I'm going to write it up here, x squared plus 6x plus 13 equals 0. I'm going to go ahead and divide both sides by 2 to get rid of it, to make it easier. And so now I have this. Okay, now this one, we already said before we can't factor that one, so we have to use quadratic formula on this to solve it. Your A is going to be 1, your B is 6, and your C is going to be 13. We're going to put it into the quadratic formula. Quadratic formula, you have x is equal to negative b, so we're going to do negative 6 plus or minus b squared minus 4ac. So 6 squared minus 4 times a is 1, c is 13, divided by 2 times 1. So we have that one. Okay. We want to keep on going with this. We already noticed that we're going to get a negative number under here, because this is 36 and this is going to be 52. So we are going to have a negative number. So even though we know that we're going to get an imaginary number I, we still want to keep on going in this one, because they still may ask you for those complex zeros, even though you won't see those actually on the graph or on your list of rational zeros. So we're going to keep on going and take this down as far as we can go. Okay, we have negative 6 plus or minus. We have 36 minus 52. At the bottom, that's going to be 2. Keep on going as far as you can go with this one. So we want to simplify the inside more. So if I do that, I'm going to subtract these 2. And so by doing that, I'm going to get 16 as the answer. So I'm going to get plus or minus the square root of negative 16 all over 2. So again, you want to have the negative 16 there, and you don't want to leave your answer you don't want to leave it like this, because this can be broken down further. The square root of 16 is 4, but then I have a square root of negative 1, that's your I. So you do want to take this down into the I form. So negative 6, I wrote 2 plus or minuses here, take out one of those. Negative 6 plus or minus 4i, all that's going to be over 2. Divide each of these by 2 and we get negative 3 plus or minus 2i. So that's going to be part of our answer, but don't forget about the 5 and the 1/2 that we had earlier. We have 5 and we have 1/2. So if they want your list of zeros, this is going to be your answer for part B. They want to know all the zeros, both imaginary and real if you have them. So here's the imaginary one, negative 3 plus or minus 2i. And then for this, the other ones are going to be 5 and 1/2 are the other ones. So that completes completes the whole list of them, and so that would be all the answers for part B. And here's your factored form for part C. Notice that the imaginary part came from this one, and that's why you couldn't factor that one anymore. The only time you can factor something is if you actually get rational zeros as a result.